varied between doing some hydraulics calculations, doing some filtration rate calculations, some molar mass percentages, and some softening. And we're going to just work through this. So I'm going to go through every single question on here. And this is mixed up. This isn't in any particular order. This is a mixed up type of math worksheet. All right, so here in the very first one, I'm going to walk you through every step, write down every formula, and so on and so forth, and explain it. So what is the volume of a tank? Exactly 25 feet long and 20 feet wide with a depth of 10 feet. So I have 1, 2, 3 measurements, and I don't see the word diameter. So that indicates to me that I'm dealing with, so it's going to be like this shape, which is a rectangular prism, or as I like to call it, a box if you've had me before. So the volume of this, we want it expressed in cubic feet and in gallons. So with this, the volume of a rectangular prism is length times width times height, or depth can be the same as the h. So here we're going to have 25 times 20 times 10. And for the fact that all the units are in feet, I don't have to convert them. And this is going to give me cubic feet. Again, like I has iterated in other videos, the Texas Instruments TI-30X2S is the calculator that I recommend. It's non-programmable and can be used on every single test. And they're only about 10 to 15 bucks depending upon where you get it. So here's my first answer of 5,000 cubic feet. Well, I know in other videos I've indicated that if I have 1 cubic foot, so that's a box, that's 1 foot by 1 foot by 1 foot, 1 cubic foot is equal to 7.48 gallons. So with that, I have to get my 5,000 cubic feet to gallons. So I'm starting with 5,000 cubic feet. It's over 1. Well, in order to cancel, it's got to be diagonal. Well, you use your conversion factor, which is 1 cubic foot to 7.48. So 1 cubic foot goes on the bottom because it's diagonal. That cancels the cubic feet. And I'm going to put my 7.48 gallons here. And it's literally just multiplied. So in order to get cubic feet to gallons, in the future, I'm going to just multiply by 7.48 to make our lives easier, all right? So 37,400 gallons is how many gallons that tank will hold. The next says the volume of a cylinder that is 15 feet high, having a diameter of 9 feet, express your answer in cubic feet and in gallons. Well, this told us it was a cylinder, but one way that I can tell is A, you'll see the word diameter, or you have 2 measurements. Because if you recall up here, we had 1, 2, 3. Cylinders only ever have 1, 2 measurements. That's how I know the difference. All right, so the volume formula for a cylinder is 0.785 times diameter times the height. It's diameter squared on the math formula sheet, but this is the way I type it out. I write it all out. So I'm going to be volume is equal to 0.785. My diameter is 9, so times 9 times 15. This will get me my cubic feet. So 953.78. I only rounded 2 decimals, cubic feet. Well, I need that in gallons, so 953.78 times by 7.48, because that gets me to gallons. Cubic feet to gallons. You multiply by the 7.48. So 7,134. Go to 2 decimal places, 0.27 gallons. I always round to 2 decimal places, except for when we do chlorination or fluoridation, I go to 3 decimal places on the million pounds and million gallons. All right. A pump fills a tank that measures 25 feet in diameter, a height of 16 feet in 1.5 hours. What is the flow rate in gallons per minute? So a lot of people try to figure out, oh man, what is my fill rate for this, okay? So there is a way of doing this, and there's a math formula for what is called, the math formula for this, and flow rate is given to you. You just don't realize it, all right? The reason for I say that is because the flow rate itself is based on the gallons per minute, right? Well, if I write that out as a unit, gallons per minute. Well, do I know how many minutes this was? Well, I can convert my hours to minutes. 1.5 hours up top, 1 hour here. So we're essentially multiplying by 60 minutes. So 1.5 times that's going to give me 90 minutes. So it took us 90 minutes to fill this. So we put 90 minutes here. Well, how many gallons was it? Can I figure that out? Well, I know it's a cylinder because you see I have 1, 2 measurements and it says the word diameter. So the volume of a cylinder is going to be 0.785 times my diameter of 25 feet. So times 25 times 25 times by 16. All right. So this is my cubic feet, 7,850 cubic feet. Well, how do I get it to gallons? Multiply by 7.48. And I'm going to put that number here, 58,718 gallons. So now that I know my gallons and my minutes, what do I do to figure out the flow rate gallons per minute? You have to divide them. 652.42 gallons per minute. A lot of times when determining a flow rate, the units are the formula for doing it. There is a pumping rate one on your math formula sheets, but this one, the units are given to you, gallons per minute, and then you just fill in what you know by solving for it. How many gallons will a water main hold that is 18 inches in diameter and 1,500 feet long? Well, I have an always rule. If you haven't taken our math class, it's always convert inches to feet, and you divide by 12 to do that. So now if you're taking an S1 or 2, there is an exemption for this. So S1 and S2 do not convert on leakage and dead end pressure, okay? Now, so how many gallons will a water main hold? It's 18 inches in diameter at 1,500 feet long. So I have to convert this to feet, so divide that by 12 to get 1.5 feet. I'm going to teach you another shortcut here too. This says how many gallons, correct? Well, the volume formula for a cylinder is 0.785 times the diameter times the diameter times the length. This gets me cubic feet. I want the answer in gallons. So if I times this by 7.48, this will get me to gallons, and I can do it in one step. And you can type it all into your calculator. 0.785 times 1.5, 1.5 times 1,500 times 7.48. So in one step, I now have my answer of 19,817. See how we have 325. So 2 decimal places, I go here and round up because the 5 are up, you round up. So 33 gallons. All right. The next one is a filtration. It deals with filtration rates, sort of. And what I mean by that is this one is asking, what is the flow in gallons per minute for a plant with 3 filters measuring 14 by 12 if they have a filtration rate of 2.2 gallons per minute. So one thing that people often get confused with filters is because this filter is 12 by 14, first off, right? So if I were to draw this, it's going to be something like this, right? It's 12 by 14, so it's a little bit longer. And it's going to have a thickness to it, a depth. Correct? Have you ever seen a filter that's just a straight filter and there's no depth to it? No, there isn't such a thing. But what a lot of people get confused with is they're thinking this has something to do with how fast a filter can filter. Filtration rates are gallons per minute per square foot. So if you imagine you were to build this as a, like, this is the surface filter, and now we're putting a grid system on it. And this grid is 12, imagine it's 12 by 14, the lines. So each one of these is a square foot. Well, what this means is 2.2 gallons per minute goes through each one of these. So this is 2.2, that's 2.2, that's 2.2. So every square foot, the area of the filter has 2.2 gallons per minute going through it. That's what this is saying. 2.2 gallons per minute per square foot. So every square foot is 2.2. So filters do one of two things. They act as a pump, or you're solving for filtration rate. And that's how filters are. People make the filtration math out a lot harder than it really is. So if you think about why I say it acts like a pump, well, think about the very first question we did on this page. Pump fills a tank, that's blah, 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 flow rate in gallons per minute. Well, what is this? What is the flow in gallons per minute for a plant? Oh, that's the same type of question as the one that we did already. So yes, the premise for solving it is a little bit different, but the filter is acting like a pump. And it's all about surface area. That's where most people get confused about filters. It's about the surface area of the filter itself. So what's the area of this filter is the first thing we need to solve. Well, it's 14 by 12 feet. So that's going to be 168 square feet. Well, 2.2 gallons per minute go through each square foot. So how many gallons per minute does each filter process? All you do is times this by the 2.2 to give me 369.6 gallons per minute. That's for each filter. So the filter's acting as a pump. But wait, am I done? No, because it says we have how many filters? So we got to times that by the 3 filters to give me 1,108.8 gallons per minute. So it's really not all that bad. The math for it's pretty straightforward, isn't it? When you break it down and understand how it works. Just identifying in the question, am I solving for a filtration rate, or am I solving for a pump rate of them filters? Is it acting as a pump, or is it filtering? So once you know that and determine which way to go, filtration calculations are not that bad. A chemical solution barrel with a diameter of 3 feet and 4 feet high is lowered by 19 inches over a 24-hour period. How many gallons of solution were used? So first off, I want to premise this with saying, starting this off with a cubic foot. 1 cubic foot is equal to what? 7.48 gallons. So the reason I'm starting with this is 1 cubic foot of 7 equaling 7.48 gallons is a universal constant. What I mean is, regardless of what, because it doesn't say gallons of water, does it? So regardless whether you put alcohol, motor oil, crude oil, you name it, mercury into these things, mercury will be in a different discussion we talk about one of these videos, but it's still 7.48 gallons. Okay, so knowing that, regardless of the chemical that we're using, it's probably bleach or fluoride acid, one of the two, it's still 1 cubic foot is 7.48 gallons. Okay, well, why is that important? Well, we'll talk about it in a second. So now let's get back to the question. So thinking about this question, it's something like this, right? It's saying it's 4 feet high and 3 feet in diameter. But what I do know is that it dropped 19 inches. So this is what's all empty in the barrel now. And we're asking how many gallons of solution were used. Well, the 4 feet is there to serve as a distractor, because we don't care about the full barrel, do we? We want to know how many gallons were taken out. Well, it dropped 19 inches in a 24-hour period. So how many gallons were used? So the 4 feet is there as a distractor. We don't care about the full volume of the barrel. We only care about the 19 inches. This is what's known as a drawdown, okay? So what you're going to do is you're going to use your 19 inches as your height, not your 4 feet. The 4 feet is there to serve as a distractor. So convert inches to feet, so divide by 12 gives me 1.58 feet for my height. So the volume of this is going to be 0.785 times my diameter. Now the diameter does matter because the diameter goes up and down as it gets drained, right? This 3 feet stays 3 feet as it goes down. But my height, that change is 1.58. Well, and it asks for how many gallons. And just like before, I can times this by the 7.48 to get it to gallons. So in one step, you can figure out how many gallons left. But the biggest thing here is to know that that 4 feet has nothing to do with solving the equation, because the 19 inches is your drawdown, and we're looking for the gallons that were used. So the 19 inches is why we use that. Nope. Okay. So this one right here. So the filter right here was acting as a pump, right? Because we knew the filtration rate. How many gallons were the flow? Now look at this. This says, what is the filtration rate? It doesn't say what's the flow in gallons per minute. So for the fact that this one's asking for a filtration rate, this one is an actual filtration. That filter is filtering. So we need to know, they're looking for the units here. What's the filtration rate in gallons per minute per square foot? So the formula for filtration rates is gallons per minute divided by the volume. All right. So, or I lied, not volume, area, sorry. Gallons per minute divided by the area. Well, we know that this is a circle because it's 16 feet. So the area of a circle is 0.785 times 16 times 16, because it's got to be in square feet. So this will give us one part of our equation. This is the easy part first. So 200.96 square feet. The next thing here is I got to get 3.2 million gallons to gallons per minute. Well, first off, my 3.2 million gallons looks like this. You need to get it to gallons first. It means you got to get rid of this big M. And to do that, you have to multiply by a million. So this is going to be 3,200,000 gallons. Well, I need to know how many minutes it is because I got to get gallons per minute for up here. Well, 10 hours or 32 hours. To convert that to minutes, you times it by 60. 1,920 minutes. So 1,666.67 over 200.96. So GPM over the area, which is square feet. And this will give me my answer. So when I do this, I get a filtration rate of 8.29 gallons per minute per square foot. That's a smoking filter. Most filters don't filter that fast. I don't know actually if any that I think do. Most of your filtration rates when dealing with like a mixed slow sand or a mixed media filter with sand, anthracite, and gravel, most filtration rates fall anywhere from 0 up to 4 gallons per minute per square foot. And 4 is on the high end. Most are in the like 1.5 to 3 range. So this is a smoking filter. To be honest, this is more indicative of what a backwash rate would be. So, all right, moving on. This one is what we call a C1V1. So an acid with a concentration of 8.2% at 650 milliliters is being reduced to 4.4% acid. How much acid is produced? So we usually convert our percents to decimals here, and you do that by dividing by 100. So the very first thing I'm going to do is I'm going to divide each of these by 100 to get them to a decimal form. So I'm going to be dealing with 0.082 at 650 milliliters and 0.044, and I don't know the volume, right? That's my question mark. So this is known as what we call a C1V1 is equal to C2V2. It's a concentration. So essentially what's happening is this acid is diluted down to 4.4%. And with it being diluted, we want to know how much acid we're going to end up with. Well, our concentration and volume for the first one are milliliters, right? So 0.082 times 650 is equal to 0.044 V2. V2 just being volume. One thing I want to caution you this with doing these on tests is making sure, because sometimes we ask you what the concentration is. So make sure volumes match. It's one of the biggest common mistakes on this. And what I mean by that is if you're doing milliliters on one side, it's got to be milliliters on the other side. If it's liters on one side, it's got to be liters on the other side. All right. That's what I'm trying to get at. It's a lot of people don't realize that the units aren't the same and they do them. And that could really come out with a wrong answer. And that wrong answer is probably on the test as a right answer, or you might think is. Okay. So all you do to solve for this is a little bit of algebra. So we multiply this one side. So we got 0.082 times 650 gives me 53.3 is equal to 0.044 V2. So you have to divide each side to get rid of the 4 here. Well, whatever you do to one side, you have to do the other. So I do the 53.3 divided by the 0.044, and it will give you how many milliliters on the other side. So this is going to produce 1,211.36 milliliters of acid. So when we dilute it down to the 4.4%, you're going to end up with 1,211.36 milliliters, almost doubling it. Okay. Now the next one is a softening type of question. What is the carbonate hardness, or what is the non-carbon hardness given the following water parameters? Well, first off, total hardness equals carbonate plus non-carbonate hardness. So you have your carbonate hardness plus your non-carbonate hardness. Well, this says alkalinity. Well, I want to tell you a little secret. Carbonate hardness and alkalinity are almost always equal to one another. There are some conditions where that's not true, but almost always. So this is usually equal to your total alkalinity. So if that's the case, if I have 335 is equal to my carbonate hardness being my total alkalinity, 189, plus non-carbonate hardness. To solve for non-carbonate, all we have to do is do the math, algebra. Subtract this from this side to cancel it out. Subtract that, and ta-da, you got our answer. So 335 minus the 189 total carbon hardness is 146 non-carbonate hardness. And this is probably as CaCO3, milligrams per liter, as CaCO3. But that's it. That's all there is to that question. So that's a little thing to keep in mind, that total alkalinity and carbonate hardness are almost always equal to each other. All right. All right. We got 2 pages left. We're getting there. A tank that measures 275 feet in diameter has a height of 20 feet is filled with a pump producing 6,250 gallons per minute. How many hours will it take? Okay, so there is a math formula on your math formula sheet when you look called detention time. And detention time is equal to volume divided by flow. But this has nothing to do. So what detention time is the theoretical time it takes a drop of water to come in one side of the tank and flow out the other side. And theoretically, the tank has got to be full first before that drop would ever flow through it. So the thing about that is detention time is also what I like to call fill rate because it's essentially the same thing. This is how long it takes to fill something. This is how long it takes water to flow through a tank. Well, it works in the same principle. There is a caveat to this. Units must match. Okay, now let me do the math and I will show you what I mean. So I need volume divided by my flow. Well, I already know my flow is 6250 GPM, gallons per minute. Well, I need my volume. So what I mean that units must match is you got to have the same units top and bottom. Well, volume, have you ever heard of a volume that comes in minutes, hours, or days? No, I wouldn't say. I don't look at a tank and go, that's 4 days volume. No, it's a million gallons. So that's what I mean by units must match. So since I have gallons per minute here, this unit must also be gallons. And why? Because when units are on top and bottom, they cancel each other out. So a tank that measures 275 feet in diameter with a height of 20 feet. So this is 275 feet in diameter. So first off, that means it's a circle. So 0.785 or a cylinder times 275 times 275 times 20 times 7.48 to get it to gallons. This question is actually inspired by a plant here in Michigan that has tanks that are 320 feet in diameter. And I think they have 6 of those tanks, if I remember right. So this is 8,881,097.5 gallons. So I need to put this over here, 8,881,097.5 gallons. Now, when I divide this, gallons goes away and it leaves me with minutes. So I'm going to end up with a unit in minutes. Divide by 6250, 1,420.98 minutes. Well, how do I get minutes to hours? Well, all I got to do is divide this, divide it by 60, and this will give you hours. So 23.68 hours. Now, in the chemistry basics portions of this, we covered how to do molar mass percents. So what we're going to do, we're going to break this down. So the very first thing I do is break down the chemical equation first. What is the percent of calcium in calcium phosphate? This is actually wrong. This is supposed to be a 2. I didn't realize I was wrong. Well, that's truly what its chemical formula. Ca3PO4 parentheses 2, not a 3. So let's go ahead and do this. So I have Ca, phosphorus, and oxygen. Okay, now I go through and determine how many each atom I have. The subscript here indicates I have 3 calciums. Phosphate, I see there's nothing there, so that means 1. But when you have a parentheses like this with the 2 outside of it, that doubles everything inside. If it was a 3, it would triple. If it's a 4, quadruple. So if this is 1, but there's a 2 on the parentheses, that means it doubles, so there's 2. Oxygen has a 4 here. The 2 on the outside of the parentheses, that means double it, so it's 8. Now I go and look up how much each one of these weighs. So the math formula sheet has the weights on it. I know oxygen 16, phosphorus is 30.97, and calcium is 40.09. Now you need to multiply these together. Or this is 120.27, 61.94. I think. Yeah. Now you're going to add all these together. 120.27 plus the 61.9. So this has a weight of 310.21. Now, in order to solve for the percent of calcium, we use the concept that I call part of the whole. So the part of is what you're looking for. So in this case, we're looking for calcium. So the part of is, it weighs 120.27, and the whole thing is the 310.21. You do the division of that, and you get 0.3877. I round that to 2 decimals to make it 0.39. So now percent times by 100, and it's 39% calcium. The next is a hydraulic calculation. An elevated storage tank that is 185 feet tall is full. After 30 minutes, the water level has been lowered by 27 feet. What is the pressure at the bottom of the tank? Now, elevated storage tanks look something like this, right? Well, they have lots of different shapes anymore, to be honest. So this is 185 feet. This is a static pressure hydraulics, and it was lowered by 27 feet. So the height of water is what determines our pressure. Well, the water is not 185 feet tall no more, is it? It is 185 minus 27, because we're looking for this height to get us our pressure. So 185 minus 27 gives you 158 feet. Well, I know that 1 foot, according to the math formula sheet, is worth the 2.31. Oh man, I got this all backwards. 1 psi is equal to 2.31 feet. Well, I use this as a conversion factor. If my feet are up top, where do they got to be to cancel? Well, they got to be diagonal to cancel. Diagonal goes here. So 2.131 feet here, 1 psi up top. So you do the math left to right like this. You're going to have 158 over 2.31 to give you your pressure. So 68.4 psi. Sulfuric acid with a concentration of 0.2 N at 350 milliliters is being diluted to 0.08 N. How much acid will be produced? This is N normality is the same as saying like a percentage. That's the concentration. So again, this is a C1V1 equals a C2V2. And being that this is milliliters, our answer here will be milliliters again. So remember, I said if we're looking at them, make sure volumes are matching. So I'm going to have 0.12 times by 350, because that's these are linked together, 0.12 at 350 milliliters. I'm diluting it to 0.08, and I do not know my volume. So again, just like before, we're going to multiply the things on the left. So I'm going to get 42 is equal to 0.08 V2. Well, you got to do algebra. Whatever you do to one side, you got to do to the other. So that cancels that. Divide the 42 by the 0.08. And it gives me 525, which would be milliliters, is equal to our V2 here. So you divide the 42 by the 0.08, because whatever you do to this side, you got to do to this side. That goes away. Top and bottom, they cancel out and divide away. Then 525 milliliters is equal to our V2. A filter that measures 18 feet 6 inches by 16 feet 9 inches is backwashed with 38,500 gallons over 10 minutes. What is the backwash rate of the filter? Okay, so I know the filtration rate, if you recall, was gallons per minute over my area. Well, what's the difference between a backwash rate and a filtration rate? Well, let's draw a filter here. Imagine it's got, a gridded pattern on it. So filtration rate goes this way through a filter, correct? It goes down through the filter, and it's gallons per minute per square foot. Well, backwash rate does what? It uses the same formula for backwash rate as it does filtration rate. That's the secret to it. It's just backwash comes back through the filter. Yes, a little bit more happens than filtering. It uplifts the media, it scrubs the filtrate off of the media so it cleans it, it washes down the trough and goes to some disposal thing. Well, backwash rates and filtration rates are still gallons per minute per square foot. So the very first thing I need to do is figure out my area because it's the easiest. Well, we have inches here. And what I tell you to do with inches, you always convert them to feet. So divide these by 12. So you're going to have 18.5 feet. And being it has two measurements, it's most likely a square because it doesn't talk about diameter, times my 16.75 feet. Because when I convert 0.9 or 9 inches, it's going to be 0.75. So 18.5 times 16.75 gives me an area. So area here is going to be 309.88 square feet. Well, I need to know my gallons per minute. Well, I know my gallons and I know my minutes. So 38,500 gallons divide by 10 minutes is going to give me 3,850 gallons per minute. This is going to be 3,850 here. And this will give you your backwash rate. So you just divide the two now. And we have a backwash rate of 12.42 gallons per minute per square foot. Filtration rates and backwash rates use the same formula. That's the biggest kicker. A lot of people get confused with that one too. So filters do two things. They act as a pump or they're acting as a filter. So you're either solving for like a pumping rate based off a filter, or you're kind of solving it as filtration rate. All right. This next one is a hydraulics flow calculation. This is the lovely Q is equal to V times A. And I will tell you how to tell the difference because a lot of people often are like, well, where do I start? What kind of question is this? So a pipe measures 10 inches in diameter, 3,500 feet long, is flushed at a velocity of 3.2 feet per second. How many gallons per minute are required to do this? So there's a couple caveats here. First off, you see the word velocity? That's what the V stands for here. Velocity is the indicator that I always use to know it's QVA. Okay, well, this looks like algebra, doesn't it? And it is, but I use what's called the continuity triangle. And you can learn more about this in the hydraulics section of this class. I'm going to go over a lot of QVA in there. So QVA, so the V stands for velocity, A stands for area, and Q is a universal for flow rate. Well, there's a couple other things about this that's got caveats to it. The area is always square feet. Velocity is always feet per second, which means the flow rate is always cubic feet per second. Well, if you watch any of the other math videos, cubic feet per second can be converted to gallons per minute. So what I do is I use the continuity triangle. So I'm going to put in my velocity because I already know it, 3.2 feet per second. Then I have 10-inch pipe diameter, 3,500 feet long. Well, do you see anywhere in here that talks about needing the length? No, area, being it's a circle, is always going to be 0.785 times diameter times diameter. So the area for QVA is always 0.785 times diameter times diameter. So the length has nothing to do with it. Well, why would we give you the length? We would give it to you to confuse you. A pipe that measures 10 inches in diameter. Well, what do we always do to inches? We convert them to feet. So that's 0.83 feet. So I have to do 0.785 times 0.83 times 0.83 is going to give me 0.54 square feet. So I'm going to put that 0.54 here. Now, how does the continuity triangle math work? Well, if they're across from each other, you multiply. And if they're above and below, you divide them. Like if they're top and bottom, you divide. So we multiply, and that's going to give us our Q. So 3.2 times 0.54 gives us 1.73 cubic feet per second. Well, I need to convert that to gallons per minute. Well, this is where they always got to go diagonal to cancel. So 1 cubic foot is equal to 7.48 gallons. It's one we've talked about a few times. And then I need to get seconds to minutes. If seconds are here, diagonal puts them up here to cancel. So 60 seconds is equal to 1 minute. So 60 up top to cancel the units like this. Those units cancel. Then you multiply this way and multiply that way. Well, 1, 1, 1, 1 doesn't do anything. So 1.73 times gives me 776.42 gallons per minute to solve for that QVA question. Now the next one is another hydraulics one. How high is the water in an elevated storage tank if the pressure is 57? So again, I'll try to make this like the new ones I've been seeing. A lot of the new water tanks look like this. They're mostly flat on the top. Saginaw's got one like this. Lansing's got one like this. Waterford or Livonia to do. Yeah, these are the new styles of them. But anyway, at the bottom here, this is 57 psi. So what we're looking for here now, we're looking for the height of the water. So I'm going to take my 57 psi, put it over 1. Well, I know that 1 psi is equal to 2.31 feet. So if psi is on top, psi diagonal to cancel goes here. So 1 psi is 2.31 feet. When I do this, I get 131.67 feet. So the water is 131.67 feet above the ground in that tank. All right. So this concludes some math that I wanted to walk through. I appreciate you all joining us, and thank you and have a great day.